Okay, in this video we are taking a look at a different way to list all the possible outcomes in different experiments. So last time we looked at sample space diagrams, which are really useful when we have two different events going on. In this case it says, what's the probability of getting 3 heads when you toss 3 coins? Okay, so here I have my 3 coins. Now if we start to try and think about the different ways we can get, or the different combinations we can get, we could get 3 tails like this. We could get that this one is heads and these two are tails. We could get this one's heads and this one is also heads and this one's tails. We could have tails, head, tails, and you can see there's lots of different possible combinations. So again, we need an organized way to work this out. Okay, so we're going to learn about tree diagrams today. Now we've got 3 different coins, so those are our 3 events. So I'm just going to mark here, this is the first coin toss, second coin being tossed, and the third coin being tossed. Now when we toss the first coin, we've got 2 different outcomes, so we can either get heads or we can get tails. Now, when we toss the second coin, we have to think about, okay, if the first one was heads, the second one could be heads or tails. Or we could have got tails for the first one, and then heads or tails for the second one. Now when we move on to the third coin, there's already a couple of things that could have been happening. So we could have got heads for the first one, heads for the second one, and then either heads or tails for the third one. Again, we could have got heads, tails, and then heads or tails. We could have got tails first, then heads, and then either a choice of heads or tails, and then we could have got tails, tails, or heads or tails. So let's look at each of these pathways. So this is called a tree diagram, and these are sort of the branches of the tree. So if we follow each one, our first possible outcome is we could have got heads and heads and heads. So I'm going to write that like this, heads, heads, heads. Then we could have got heads, heads, and then tails. Next outcome is we could have got heads, tails, heads. Or we could have got heads, tails, tails. Now, this side of our first coin is getting tails first, then heads, heads. So tails, heads, heads. We could have got tails, heads, tails. We could have got tails, tails, heads. Or we could have got 3 tails. So these are all the different possible combinations that we could get when we toss 3 coins. So this tree diagram gives us an organized way of keeping track of all the combinations. So we have got 8 outcomes, and only one of them gives us heads, heads, heads. So we only have a 1 in 8 chance of getting 3 heads. Okay, imagine you're writing a test and you've got 2 multiple choice questions. Each question has 4 options, A, B, C, or D. So we have Sam, who didn't study for his test. He randomly guessed that B for the first question and C for the second question. So we want to work out the probability, first of all, that he got both questions right, because obviously that's what he's hoping for. And then we're going to work out the probability that he got one of his questions right. So we're going to start by drawing a tree diagram so we can list all of the different possibilities. So on question 1, he had 4 options, A, B, C, or D. And then on question 2, he has the same 4 options. So out of this branch, we're going to draw 4 more for each one. A, B, C, or D. If he chose B, he still had the options A, B, C, or D. And so on. So now that we've drawn our tree diagram, we can list all of the different possible combinations of choosing 2 different answers. So along this first branch here, we could have chosen A and A, so 2 A's. The next branch would show A, B, A, C, and A, D. Then, if we go along the second branch, so imagine Sam chose B as his first one, and then B as his second one. So we've got BA, BB, BC, and BD. Then we could have chosen C and A, C and B, C and C, C and D, and the last one, D and A, D and B, D and C, and D and D. So you can see now that there's actually 16 different combinations of answers we could have chosen. So Sam chose B, C as his guess. So he chose B, C. So the probability that he got that right, there's only one way we have B, C there. So the probability he got both of them right is just 1/16. Okay, so that's a pretty low probability. Now let's look at the probability he got only one of them right. So in that case, he could have chosen B as the correct first answer, but the wrong second answer. So there's 3 there that I've circled in blue. Or he could have chosen C as the correct second answer. So C second is here, here, and here. So there's actually 6 different ways he could have got one question right. So the probability he got one of them right is 6/16, okay, which simplifies to 3/8. Notice that probability that he got one right is actually still less than a half, so there's less than a 50% chance of you guessing 2 correct or even one correct answer on 2 multiple choice questions. So the moral of the story is study for your test.